Is the board visible to all of you? Is the board visible, guys?
Yes, sir.
Yes, sir.
So yesterday we left out one question, so we will just quickly do that question. It was related to human eye again, and let us quickly complete ray optics, and we'll move on to the review of wave optics. Right. So hopefully we can complete everything of wave optics by today. Okay. So if we just go back, I think this was the question, I believe. Right. A person wears eyeglasses with power of minus 5.5 diopters, it seems, right? And they're asking us for a distant viewing, okay, for to view the far objects, right? The person has to wear eyeglasses of minus 5.5 diopter. His doctor prescribes a remedy of 1.5 diopter, means overall you should have 1.5 diopter for his near vision again. What should be the focal length of extra lens which should be pasted over the lower section of the eyeglasses for correct vision? So it's a very simple question. It is based on again a combination of lenses only. If two lenses are in contact, what is the effective power? Beta? Effective power will be given as sum of individual powers. Now the doctor has prescribed a remedy of 1.5 diopter. It means the effective power has to be 1.5 diopter. For the eyeglasses, the power is already given as minus 5.5 diopter, guys. They're asking us to find what is the focal length of the extra lens that has to be pasted over the eyeglass. So when, if I assume this is the eyeglass, if I am pasting one more lens, will these be two lenses in contact or not? Yes, whenever two lenses are in contact, effective power will be P1 plus P2. So overall, the doctor is prescribing a correction of 1.5 diopter. So what we should do, final effective power should be 1.5 diopter, guys. From there, we can find out the P2 value. What will I get P2 value as? I think you will get it as 7 diopter, right? And implies, how will you write power of a lens? Power of a lens will be given as 1 by focal length of the lens, which is 7 diopter. Diopter is nothing but meter inverse, guys. So I can write it as 7 divided by 100. So what will F2 value be? It will be 100 divided by 7 centimeters again. This centimeter inverse we can write. So you will get it around 14.3 centimeters, guys. This would be the focal length of the lens that has to be added on the eyeglasses such that the effective power is going to become plus 1.5 diopter. Is that clear? Understood, all of you? And one more question which I think we supposedly did wrong again. That is this question, guys, which is one cannot see through fog because of scattering, guys. It is not refractive index of fog is very high, right? It is due to light is being scattered by the droplets present in the fog. We cannot see through fog, guys. Okay, it is not refractive index of fog is very high. It may be dense again, right? You are already aware. We have said, we have talked about one statement. uh, Whichever is a denser medium, if a material has more mass density, is it necessary to have more optical density, guys? No. So fog appears to be dense, but its optical density will be less, guys, than the ordinary light. So light is scattered by the droplets present in the fog. That is the reason one cannot see through fog. Okay, so this one correction you can make again, right? So if we let us proceed to the other questions again quickly. I think we have discussed yesterday till where are we? Right. So let us do these questions. To get three images of a single object, one should have two plane mirrors inclined at an angle. How much they are asking? So what is the number of images formed? Here they have said the number of images formed are how much, guys? Number of images formed they have given as 3, right? If you see, we will try to calculate n value again, as you all know, which is given as 360 degrees divided by theta. Now this n can either be odd or even. If it is even, the number of images formed will be n minus 1. If it is odd, for symmetrical alignment, n minus 1. For unsymmetrical alignment, n. Yes or no? So what is the number of images formed, guys? Either number of images formed can be n or it can be n minus 1. Yes or no? If this value is even, number of images formed will be n minus 1. If this value is odd, number of images formed will either be n or n minus 1. So directly I can conclude that the number of images formed can either be n or n minus 1. So from this what we can write? N value will be equal to 3 and n minus 1 value will be equal to 4. If n value is equal to 3, what will theta value be beta? It will be 360 degrees divided by n, which is 360 degrees divided by 3, which you will get it as 120 degrees. Is there any option like 120 degrees? No, there is no option like 120 degrees. So n minus 1 value should be 3, guys. So what will I get n value here? I'm going to get n value as 4. So what we can write theta value in second case? We can write it as 360 divided by 4, which turns out to be 90 degrees. So for one object, in order to get three images by combination of two plane mirrors inclined to each other, the angle between the mirrors can either be 120 degrees, which is not there in the options, or it can either be 90 degrees, guys. So what will our answer be? 90 degrees should be our answer. Is that clear? Yes or no, everyone? I hope it is clear,
Yes, sir.
right? So always remember number of images formed can either be n or it can be n minus 1. Okay. Next case, if you look at the question, dispersive powers of glasses of lenses used in achromatic converging pair are in the ratio 5 is to 3, it seems. So they're asking if focal length of concave lens is 15 centimeters, then the nature and focal length of the other lens will be. What is the condition for achromatism, guys? Right, they are lenses placed in contact, let us consider. So what is condition for achromatism? If lenses are placed in contact, we have talked about condition for achromatism. What is the condition for achromatism? We will write omega 1 p1 plus omega 2 p2 should be equal to 0 or not? Yes, it should be equal to 0. So what are we going to get? Omega 1 p1 should be equal to minus omega 2 p2, right? So one of the lens is concave lens. What should be the focal length of the other lens and what should be the nature they are asking, guys? So from this, if they are asking us to find out p2 value, what we can write it as? Can I write it as minus omega 1 by omega 2 into p1 or not? Yes or no? So what will I get here? 1 by f2 value will be minus of omega 1 by omega 2 into 1 by f1, or f2 value I can write it as minus omega 2 by omega 1 into f1, guys. So omega 1 by omega 2 value is given as 5 is to 3. So what will omega 2 by omega 1 value be? 3 is to 5. One of the focal length is given as 15 centimeters, but it is concave. For concave lens, focal length will always be what, beta? Negative, right? So you will get 5 ones, 5 threes, minus into minus will become plus. So what will I get the value of f2 as? I will get it as plus 9 meters. So is focal length positive or not? Because focal length is positive, what is going to behave as? It will behave as a convex lens. So what should be the nature and the focal length of the other lens, guys? It should be convex and focal length should be 9 centimeters. So this is our condition for achromatism. At what condition is this? Lenses are placed in contact. When lenses are placed in at some separation, what should be the separation beta? The d value separation between them should be omega 1 f2 plus omega 2 f1 divided by omega 1 plus omega 2. This is the condition for achromatism if two lenses are placed at some separation. When they are placed in contact, omega 1 p1 plus omega 2 p2 should be equal to 0. And when they are kept at some separation, what should be the distance between the two lenses, guys? It will be given as omega 1 f2 plus omega 2 f1 divided by omega 1 plus omega 2. Is that clear, all of you? Yes or no?
Yes.
Yes, sir.
I hope it is clear, right? Next question, if we see, a converging lens has been given of power 2 diopter is placed in contact with another lens of power minus 1 diopter. Contact mein hai. So again, obviously, I can write effective power will be what, beta? Sum of individual powers, which is 2 diopter plus of minus 1 diopter. I am going to get it as 1 diopter. This is our effective power. So power is positive, means it should be either a convex lens or a concave mirror. All the options are lens only, so it should be a convex lens, guys. And how can I write power in case of lens? 1 by f effective we can write, which is 1 diopter. Diopter is nothing but meter inverse, guys, so I can write it as 1 by 100 centimeter inverse. So from this, our effective focal length will be 100 centimeters. So focal length is positive, so answer should be a converging lens of focal length 100 centimeters, guys. Clear, all of you? Yes or no, everyone?
Yes, sir.
Yes, sir.
Next, let us see the next question. Quickly complete it and we'll move on to wave optics, guys. Hopefully, we can start problems of wave optics also, if possible. A prism is made of glass of refractive index root 3. Prism is given. Refracting angle of prism is A. If angle of minimum deviation is equal to A, so what they have given here? Minimum deviation value is equal to 8 seems. They're asking us to find out what is the value of A. So again, direct concept, mu value, how will it be written as, guys? Sine of A plus delta minimum divided by 2, whole divided by what? Sine of A divided by 2. So mu value is given as root 3. Let us keep that aside as of now. But A and delta minimum both are same or not? Yes, they both are same. So what we can write it as? Sine of A plus A whole divided by 2 whole divided by sine of A by 2. So this can be written as sine of 2A by A will be sine A divided by sine A by 2. Now here we are going to use a very, very important formula, guys, which is sine 2 theta. What is sine 2 theta? Is it 2 sine theta cos theta or not? So in the same manner, what we can write sine A value, if I assume this to be 2 theta, I can write it as 2 sine A by 2 cos of A by 2 whole divided by sine A by 2, guys. This is our mu value. So what we can cancel out? Sine A by 2, sine A by 2 will get cancelled out. Mu value is given as already root 3. So root 3 divided by 2 can be taken as cos A by 2. For what angle of cos will the angle be will the value be root 3 by 2? For 30 degrees or not, guys? What we can write? A by 2 value will be equal to 30 degrees. So what will A value be? A value will get it as 60 degrees, guys. Understood, everyone? It is also very important question, guys. Did you understand? Yes or no?
Yes, sir.
Right, very important question based on refractive index, right? It has been asked once, I think, maybe which NEET exam, I'm not sure exactly, but you got this question, guys. Okay, understood, everyone?
Yes,
Yes,
sir.
sir.
So they will ask you if minimum deviation and angle of prism are same, what is refractive index? So what will refractive index be, guys? It will be 2 cos A by 2, guys. It will be 2 cos A by 2. Okay, that is also one question that can be asked. Next, if we see a compound microscope has a magnification of 30 when final image is formed at 25 centimeters, it seems. When final image is formed at 25 centimeters, what is the condition? Whenever final image is formed at 25 centimeters, which eye?
Trained eye.
Strained eye. Compound microscope has been given. What is the magnification produced by the objective if the focal length of the eyepiece is 5 centimeters? They're asking. Again, a direct question, guys. What do we write in this case? The total magnification of compound microscope will be given as magnification of objective into magnification of eyepiece. Right. What is the function of eyepiece? What is the function of eyepiece? Does it have same function as a single convex lens used in a simple microscope or not? And in strained eye, what will I get this as? M naught into 1 plus D divided by Fe. So what is the value of M here? M value total magnification is given as 30. They're asking us to find M naught value. 1 plus what is D value, beta? 25 divided by what we can write? 5. So 30 value will be M naught into, you will get it as 6. So what will M naught value be? M naught value will be 5. But it will be negative, guys. Okay. So here they are asking only magnitude again. So 5 will be the magnification produced by the objective. Understood, everyone? Whether it is a compound microscope, whether it is an astronomical telescope, whether it is a terrestrial telescope, Galilean telescope, magnification will be given or magnifying power will be written as magnification, product of magnification of objective lens and eyepiece lens, guys. Clear, all of you? Yes or
Yes, sir.
no? I hope it is clear. Now, next question. They're asking us what is the effect of on the image formed by the convex lens if the central portion of the lens is wrapped in black paper. Okay, so when this part is wrapped, what is going to happen? I'll just show you here, guys. If I take this as the object, right? Now, from real object, how will the rays be? Are they going to be divergent or not? So you can take this particular ray. Okay. You can also take this particular ray. You can also take this particular ray, guys. So three rays are incident. Okay. Which ray will undergo refraction? The above ray and the below ray. They are going to undergo refraction. But this middle ray will not undergo refraction because it is incident on the black paper, guys. So obviously these two rays are going to undergo refraction. So can I say they are going to get refracted and an image will be formed or not? Yes, image will also be formed, guys. Now please tell me, if there was no black paper kept at the central portion, then you would have also had one more line like this, one more light ray like this. Okay, so more number of light rays would have reached point I. More number of light rays are reaching means more bright will be the image, guys. But here in this case, because central part of the lens is wrapped up with a black paper, although image will be formed, but the number of refracted rays will be lesser now. So brightness of the image will be lesser. Intensity of the image will be lesser. So will image be formed? Yes, definitely image will be formed, guys. Right? The full image will be formed, but it will be less bright. Why it is less bright? Because initially this part was available for refraction. Now, on placing the black paper, this part is not available for refraction. So the light, the refracted light will be less in amount, guys. So that is the reason we will say that image will be formed, but it will be less bright. Clear? Understood, all of you?
Yes.
Right. Now you please see, a person can see clearly up to a distance of 30 centimeters only, it seems. Okay. He wants to read a book placed at a distance of 50 centimeters. Yes or no? What is myopia again? Nearsightedness, right? Hypermetropia, far-sightedness or long-sightedness. Yes or no? So what is a myopic eye? For myopic eye, near point will be 25 centimeters only, but far point will be less than 20, less than infinity. Again, always remember, if I take a normal eye, guys, we have a normal eye, we have a myopic eye, and we have a hypermetropic eye, guys. You have hypermetropic eye also. So normal, you have normal eye, myopic eye, as well as hypermetropic eye. So for normal eye, near point and far point, if we talk about, guys, so near point will be 25 centimeters, and for myopic eye also it will be 25 centimeters only. But for hypermetropic eye, it will be more than 25 centimeters. Whereas if I take far point for a normal eye, it is infinity, guys. Whereas for myopic eye, it is less than infinity, because it is we can see near objects clearly, but far objects will be blurred, guys, because the near point, the far point got reduced here. In the same manner, hypermetropic eye, it is far sightedness. So object you place at any distance at a very far separation, it will still be so far point for a hypermetropic eye and normal eye are same. Near point for a normal eye and myopic eye are same. Okay. For myopic eye, far point will be less than infinity. For hypermetropic eye, near point will be more than 25 centimeters. Is that clear? So he can see only up to 30 centimeters, it seems. Now, I have to increase it to 50 centimeters. Yes or no? So if I want to increase it to 50 centimeters, means I have to increase the far sight, guys. So in order to increase the far sight, I will use a concave lens. When I'm using a concave lens, power of the lens should be negative. So but in the options, all are negative only, so we need to find it out, guys. So what we can do here, we can use lens formula. We can apply 1 by v minus 1 by u will be equal to 1 by f, guys. Okay. Now let us try to understand. A person can clearly see up to a distance of 30 centimeters. He wants to read a book placed at a distance of 50 centimeters. The object is placed at 50 centimeters. The image of that object should now be formed at 30 centimeters, guys. So if I take that case, I'll get it as 1 by, you can take the sign convention. You'll get it as minus 30 here, minus of 1 by minus 50 you will get, guys, which will be 1 by f value. So what I'll get 1 by f value as, I'll get it as 1 by 50 minus 1 by 30. So 1 by f value can be taken as 30 minus 50 divided by, you can take 1500 or not, guys. So you'll get it as how much? Minus 20 divided by 1500. Yes or no, all of you? Which turns out to be how much? Minus 1 by 75? Yes or no? Minus 1 by 75. This will be in centimeter inverse again. So if I want to find it in meter inverse, what will I write power as? Power will be 1 by f, but I'll write it as minus 100 divided by 75, which is minus 4 by 3. Turns out to be minus 1.33 diopters. Okay. Right. So please remember these cases. Normal eye, near point 25 centimeters, far point infinity. Myopic eye, because it is near sightedness, it is easy to see, we can correctly view near objects. So near point is not going to change, but far point will become less than infinity. Hypermetropic eye, guys, right? The near point will be more than 25 centimeters. And because it is far sightedness, you can see far objects clearly. Far point will remain same. Clear, all of you?
So how did it become 100?
How did we?
How did we take the numerator as 100?
How did we take the numerator?
Yes, so we had got minus 1 by 75. Then how did we got as minus 100?
If you don't want to take minus also, it's not a problem again. Right? If you take 30 centimeters also, right, you have to get a erect image, no? See, I can, if you are standing in front of me, I will be able to see an erect image of yours. Yes or no? You take convex lens. So when will I get erect image?
And kept that focus.
In between focus and optical center. So from optical center to focus, you are measuring opposite direction of incident rays. That is the reason we'll take it as negative.
So मेरा doubt ये था कि why did we take, I mean, how did we got 100? So we got minus 1 by
Where did I get 100?
So
हाँ, वो सेंटीमीटर में था ना, तो मैंने मीटर में कन्वर्ट किया है.
yes.
Because I have to write in diopters. Right. Dispersion. Next question, please. Let us see. Dispersion of light in a medium implies that. What is dispersion implying again? See, guys. Definitely 5 to 6 questions will be directly statements, because that has been the scenario in the past 3 years, guys. Right. 5 to 6 questions are coming like statements only. So dispersion of light in a medium implies that. What is happening? Let us try to understand. Light of different wavelengths travel with equal speed in medium, it seems. Is that possible? In a medium, refractive index will be same. Yes or no? Mu value is given as C by V. Right? Different color lights will have different refractive indices. Means, will they be moving with different speeds or not? C value is constant, no? This value is constant. But mu value, is it same for every light? For VGR lights, is it same in a medium? No. If mu is changing, then obviously V value will change or not? If V is changing, means lambda is also going to change. So light of different wavelengths travel with equal speed in a medium is wrong, guys. They will travel with different speeds only. Lights of different frequencies will travel with equal speed, it seems. Again, no. Right? They are not going to travel with equal speed. They are going to travel with different speed only. Refractive index of medium is different for different wavelengths. Is that correct? Is that correct? So it is given as wavelength in vacuum divided by wavelength in medium or not? So for different wavelengths, you will have different value of refractive index, guys. So third statement will be the correct statement again. Understood, all of you? So dispersion of a light in a medium implies that refractive index, out of the given options, the third one will be the correct. Refractive index of medium is different for different wavelengths. Clear? Yes or no? Next, let us try to see this question. The radius of curvature of convex face. Radius of curvature of convex face of a plano-convex lens. Batao bhai, what is the focal length of plano-convex lens?
R by mu minus 1.
R divided by mu minus 1. Yes or no? They're asking the radius of curvature is 12 centimeters. Refractive index is 1.5. What is focal length in air only? They're asking, guys. So what will it be? 12 divided by 1.5 minus 1, which turns out to be 12 divided by 0.5. which will be 24 centimeters. Direct question again. It will be 24 centimeters. Right. Next one again, if you see, magnifying power of a compound microscope is high. When will magnifying power of a compound microscope be high? Again, let me just write the magnifying power which I have written just now, guys. What is magnifying power given? Basically, if I write along with sign convention, in relaxed eye condition, it is given as minus V naught by F naught into D divided by Fe. But this will also be approximately equal to minus LD divided by F naught Fe, guys. Okay. This is in which condition? This is in your relaxed eye condition, or object is placed at far point. In the same manner, what is the other thing? I am going to get it as minus V naught by U naught into 1 plus D by Fe, guys. Or I can write it as approximately equal to minus L by F naught into 1 plus D by Fe. Which case is this? This is our case for strained eye condition. This is the case for strained eye condition. Now you see, both focal length of objective and focal length of eyepiece are in denominator. Magnifying power and focal length of objective and eyepiece, are they inversely proportional or not? So if I want the magnifying power to be high, denominator should be less, right? So focal length should be less. But if focal length is less, what should power be, guys? Power will be more. So magnifying power of a compound microscope is high. When will it be high? If both objective focal length and eyepiece focal length, if they are less, then our magnifying power will be high. So both objective and eyepiece are of high focal length. It is wrong. Why? Because I am going to get less magnifying power in this case. Objective has long focal length, eyepiece small. This is also wrong. Objective short and eyepiece large. This is also wrong. Both objective and eyepiece should have short focal lengths, guys. So when they have short focal lengths, their powers will be more. If their powers are more, then the magnifying power of the compound microscope will be high. Understood? Yes or no?
Yes, sir. Yes, sir.
One more, you see. Two lenses of achromatic doublet should have. What are they asking? Two. What is the condition? Omega 1 P1 plus omega 2 P2 should be equal to what, beta? 0. Yes or no? This is the condition again. So what we can write? Omega 1 P1 should be equal to minus omega 2 P2. Can I write or not? So what is the condition here? Product of dispersive power and power of the lens should be equal, guys. So what is minus sign indicating here? Their natures will be opposite, but the product of the dispersive power and power of the lens, they should be constant. So I can say omega 1 P1 should be equal to omega 2 P2. Wherever you see equal lens power will be wrong, guys. Equal dispersive power will be wrong. Equal ratio of lens power and dispersive power is also wrong. Equal magnitude of product of lens power and dispersive power will be the correct statement, guys. So two lenses of achromatic doublet should have same value of product of lens power and dispersive power. Clear? Is that clear? Let us see next question. When light ray enters a glass slab from air, so when it is entering glass slab from air, what will happen to refractive index? From air it is entering glass slab. What will happen to refractive index? Increases. If refractive index is increasing, what will happen to speed? Decreases. What will happen to wavelength? Decreases. What will happen to frequency? Frequency, beta? No change. It is independent. So what would be the answer? Speed will decrease, wavelength will decrease. Speed increases, wrong. Frequency decreases, wrong. Wavelength decreases, correct statement, guys. Clear? Understood, everyone? As it is moving from air to glass slab, refractive index will decrease. Refractive index is inversely proportional to speed in medium, and it is also inversely proportional to wavelength in medium, guys. Understood? Yes or no? We'll come back to the square question. Let us quickly see the other simple questions, guys. Now they have given this case, the deviation of a ray produced by a thin prism, it seems. How much will be deviation? Delta value We all know for thin prism it is given as mu minus 1 into A. Optical fibers are based on which phenomena, guys? Optical fibers, they are based on total internal reflection. We have studied about something called as acceptance angle in that, guys. We have also studied about numerical aperture again. Okay. Optical fiber will have core and cladding. Core will have more refractive index compared to cladding, guys. What is the reason for reddish appearance of rising and setting sun? Why is it? You might have studied this also. It is because of scattering of light, guys. Right. Another question you see, the refractive index of thin prism for red again. So mu r is given as 1.52. Right. Violet is given as 1.62. Yellow it is given as 1.59. I have already said you refractive index of yellow light can be approximately taken as mean refractive index. They are saying that the mean deviation is given as 4 degrees. What is the angular dispersion produced by the prism? What is angular dispersion basically? Theta is the angular dispersion. It is given as what, beta? Deviation in violet light minus deviation in red light. Or I can write it as mu v minus mu r into A. I don't know the value of A. I have to calculate the value of A. Although I know mu v value. What is mu a value? 1.62. What is mu r value? 1.52 into A you can write. So this will be 0.1 into A. A I don't know, guys. But how can we calculate A value? By using delta. Delta is what? Mu minus 1 into A we can write. So 4 will be equal to, mu value can be taken as 1.59 minus 1 into A. So what will A value be, beta? Can I write as 4 divided by 0.59 or not? Near about 4 divided by 0.6 also you can take. So what will I get here? 0.1 into 4 divided by 0.59 we are going to get, guys. So this will be around 0.4 divided by 0.59. We can take approximately 0.6 in denominator, 2 by 3. So near about 0.68 you will get, guys. Clear all of you? Yes or no? So from mean deviation and mean refractive index, we were able to calculate the value of angle of prism. And you know the angle of prism. Already they have given mu v, mu r. We calculated A. So from there we can find out the angular dispersion. Angular dispersion is basically given as the difference in deviation produced in violet light and red light, guys. Clear? Understood all of you? One question is pending. Let us try doing this question, which is a good question, guys, again. Okay. Square wire of side 3 centimeters is placed perpendicular to principal axis, it seems, at a distance 25 centimeters from concave mirror. So what do I have? I have a concave mirror, something in this manner. The outer surface will be silvered in case of concave mirror. Let us imagine this is our principal axis. So I am taking principal axis along x direction. What will be perpendicular to x direction, guys? X direction will be perpendicular to YZ plane, guys. Right? How can you imagine plane surfaces? I've already told you the wall in front of you, the wall at the back of you. These are your XY planes. The wall to the right of you, the wall to the left of you. These are your YZ planes. Right? The ceiling and the floor. These are your XZ planes, guys. So I am taking principal axis to be along x-axis. So what will be perpendicular to x-axis? Will YZ plane be perpendicular to x-axis or not? Yes or no, yaar? Yes. So where is
Yes.
the object placed? So I am just showing you, so you can consider it is placed something in this manner, guys. Object is placed like this. So good question again. Okay, object is placed like this, and what is the height of the object here? It's clearly given. It is 3 centimeters. What is the object distance, beta? Object distance. It is 25 centimeters, but I'll take that as negative. Now, can I apply? They're asking what is the area enclosed by the image, guys. So I know focal length. I know the object distance. Can I find magnification? What will magnification be? Good question again. What is magnification going to be? In terms of focal length and object distance, what does it get, beta? F divided by F minus U. What is focal length? For concave mirror, it is negative. How much is it given? Minus 10. Again, you can write minus 10. Minus of object distance. Again, all the measurements should be taken from pole. Incident rays will be along positive x direction. But object distance is being measured opposite direction of incident rays. So they will be taken as negative, guys. So what is magnification for us here? Minus 10 divided by 25 minus 10 will be 15 or not? Yes or no, all of you? Right? So what will I get it as? Minus 2 by 3. Is that clear? Is that clear? Now please tell
Yes,
me.
sir.
How can I write magnification as? Can I write it as height of the image divided by height of the object or not? Which is minus 2 by 3. So here what is the height of the object? Again, it is being measured perpendicular to principal axis, guys, right? And along positive y direction. So what will height of the image be? It will be minus 2 by 3 times of height of the object, which I can write it as minus 2 by 3 times of height of the object is 3 centimeters. I'll get it as minus 2 centimeters, guys. So what is minus sign indicating here? Minus sign indicates it will be an inverted image, guys. Where what will it be? It will be an inverted image again. So each side has 2 centimeters length. So what would be the area again? The area will be 2 square, which will be 4 centimeters square, guys. Clear, all of you? Understood or not? Is that clear, Vita?
Yes, sir.
Yes, sir.
Right. So this would be your questions from ray optics. Any doubt in the questions of ray optics? Right.
Sir,
Those who want to score more marks in physics, right? Like more than 120 in physics. For them, I'll in group anyhow I'll share questions, guys. Right? I'm going to share some questions more than 120, 140 in physics. Whoever are interested, I'll share some questions. You can focus on doing those questions if you wish to. I'm not forcing anyone. I'll just pose the questions, guys. Okay. Clear, all of you? Yes or no? So you'll get direct questions like this in NEET exam also. Very small changes you will get. But you should be very much careful with the concepts of ray optics. And while you are solving questions of ray optics, you need to be very careful with sign convention, guys. Clear, all of you? Yes or no?
Yes, sir.
Right. So someone yesterday asked, sir, explain rainbow and all. So I'll just quickly just show you what is going to happen in that, guys. Okay, so rainbow again, how it is formed, I'll tell you, and how will secondary rainbow also be formed, I'll tell you. So for that purpose, what we'll do is, so let us take a water droplet, guys. If I take a water droplet, usually when will rainbow be formed? When will rainbow be formed? When rain is falling as well as little bit of sunlight is there. Yes or no? Yes or no, yaar?
Yes.
No.
Yes, sir.
Yes, sir. Huh. So now you see, guys, let us imagine there is a certain light ray falling on this water droplet. Okay. So you can consider this will be the point of incidence, right? Point on a curved surface will behave as plane surface.
Yes,
And
sir.
if I want to draw a normal to this plane surface, is it going to pass through center of curvature or not? Certainly it will be passing through center of curvature. Is it traveling from rarer medium to denser medium, guys? Yes or
Yes.
no? Yes. So what is going to happen? It will bend towards the normal. Right? This is how primary rainbow is formed again. Now what is going to happen here? So one refraction took place, guys. Now you see it is traveling from where to where? This refracted light. What is going to happen in this situation now? This refracted light will now undergo internal reflection, guys. It will undergo what? Internal reflection. So refraction took place. Here what will happen? Internal reflection will take place. Now you see this particular light, while it is coming out, right, it will split into different colors here. It will split into different colors. Red will be above, violet will be below, guys. This is formation of your which rainbow? Primary rainbow. What took place? Here you see refraction took
Refraction.
place. Here you see internal reflection took place. Here you see what is taking place? Dispersion is taking place, guys. Clear? So primary rainbow is formed because of three processes again: diffraction, internal reflection, as well as your dispersion again. Okay, right? And the colors will be above you will have red, below you will have violet. Whereas for secondary rainbow, again you will have one more internal reflection taking place here. Okay, and the colors will be violet will be ahead, above, and red will be below, guys. Okay, whereas the brightness or the intensity of the secondary rainbow will be lesser than the your primary rainbow. Okay, is that clear? Hello, yesterday people.
Yes, sir.
So what would have happened if I would place my copper wire in the XY plane?
Copper wire.
In the XY plane. I mean, how
Where
would have been formed?
in which case?
So in the second last question, just before this question.
The square one.
Yes, the square one.
What will happen if?
So in this question, we have placed the wire.
Very simple. We did that question. No, again, you placed a certain wire. So even if you are placing a copper wire, what is going to happen in that case? Same like this. You are saying square frame made up of copper.
Yes, the same like this, but in XY plane. I mean, not like vertically. I mean, in XY plane.
XY plane will also be perpendicular only. No. No,
So
you are
but
saying this case. This case. Acha, ठीक है. This case. You are saying this case. No, like this.
yes, like that.
So in that case, what you should do is you will take this as one object. This one you will take as one object and find its corresponding image. So let us say its image is formed somewhere over here. Okay, right? And again, closer the object, will image be far or not, guys? As you move object closer to the mirror, image will go away. So you can say this is one part and this is the other part. So let us imagine this to be the first part and this to be the second part. So for second part, you will find image formation. Let us say it is formed somewhere over here. And first part, the image will be formed somewhere over here. Okay, the thickness you can take it almost the same thickness only, right? Or if not, you can take here length of the object you can consider again. So anyhow, what we can do is this part, if you take some object distance is given, let us say 3 centimeters is given here, and focal length is also given. Let us imagine object distance is known, focal length is known. Can you find image distance? From here to here, you can find image distance in first case, or this is second case, let us say. No, first case only, it will be moving away again. Right, in the same manner, from here to here, you can find out second case. So what will this be, beta? This is going to be your, it will be in the form of a trapezium again. I think yesterday we have seen, I said it is not required again. It will be in the form of trapezium like this. This area will get. Okay, so when it is placed along the principal axis, what you will do is you will take the two heights separately, two sides separately you will take. Okay, but if it is a short object, then no change again. It will again be in the form of a square only. Clear?
Yes, clear.
For this object, you will take, find the corresponding image. You take this object, find the corresponding image. Okay, and heights also you can find by using magnification. So it will appear in the form of a trapezium again. Understood, all of you? Any doubts in ray optics? Do you have any doubt in ray optics, all of you? Everyone. Maximum things we have covered in ray optics, including the review and some questions. Right? I have given you a task, guys. I have asked you people to complete the previous year questions. I am not sure how many of you have done. Maybe 70, 80 previous year questions will be there in ray optics. Please ensure that you are solving all those questions, guys. Is that clear?
Yes.
Right? All the previous year questions you please solve so that tomorrow when you are writing the exam, it will become easy for you. And what all doubts are there, get them cleared, guys. So one chapter
Sir,
we have.
sir,
Sir,
is
is
it
it?
necessary to solve from 1990s?
It will give a better idea again. Even if the paper is moderately tough, you will be able to get the questions. Now most of the people will think for a easy way out, guys. The easy way out is you will take NEET questions from 2013, leaving out 2015, right? 2013, 14, 16, 17. You will take only NEET questions. You will solve, right? But maybe there can come a question from AIPMT. One AIPMT question was there somewhere. Let us say maybe that question may be repeated tomorrow in the exam. When I say tomorrow in the exam, it may be in NEET exam also. So it is obvious to solve questions. Again, I'm not saying 90-90 question and all, but basically AIPMT, whatever is there from 2000 at least you solve, guys. Around 20 years back, last 20 years papers. Is that clear? It's better to solve because, see, if you are already acquainted with a certain question, then it will be easier for you to solve it when you are seeing it the next time, the second time. So if we solve limited amount of questions, we will be acquainted with limited set of questions, limited set of problem solving techniques. If you solve and practice more questions, you will be acquainted with more problem solving techniques, right? More concepts you will get acquainted. And obviously the tendency of scoring the marks will also increase. Okay. So I'm not forcing anyone to do this or that again, but it's better if you solve. At this point of time, I don't think 50 questions in a chapter should be a burden to all of you guys. At least ensure that you're solving 50, 60 questions in a chapter. Okay. Is that clear, all of you?
Yes, sir.
So let us move on to our next chapter. Hopefully, we'll complete this chapter with questions by tomorrow. And as soon as this chapter is completed, we can have a test, and you can write the test for 1 hour. You can write and you can sleep, guys. 10 to 11, you can write the test and you can, if you want to sleep. If not, you want to study late night, you can study. Right. So wave optics basically is a very simple chapter, right? Because we can easily predict the questions from this chapter, guys. Either you will get questions from Young's double slit experiment, diffraction, polarization. In polarization, you have two concepts. One is polarization by using polarizer analyzer combination. Other is polarization by reflection, right? Which involves Brewster's law. Diffraction, you have 4 or 5 formulas only, right? What would be angular position of nth minima? What will be angular position of nth maxima? What is angular spread of central maxima? What is width of central maxima? What is width of any other fringe? What would be the intensity of nth maxima? These 6 formulae are there in diffraction. Whether you understand the concept of diffraction or not, even if you remember the 6, 7 formulae, you will be able to solve questions. However, Young's double slit experiment is very important, guys, but it will anyhow cover a little bit of waves also, right? So in wave optics, little bit of waves is also covered. So if you are fortunate enough, if question is coming from interference, right, you will be able to do the question in waves also. Okay. So without further ado, let us just go ahead with this chapter and try to complete the concepts of this chapter so that tomorrow we can discuss the numericals of this, guys. If the class was in morning, I could have taken 2.5 hours because it's night again, right? You should understand. I also have some constraints. So if it was morning, then I would have utilized at least 2.5 hours, and we would have done some questions also. Nonetheless, we can do it for some other day. So what is the coherence? What is the meaning of coherent source, guys? So remember, dependent sources will be called as coherent sources again. If two sources are dependent, they will be coherent, right? So two sources emitting light of same frequency and in same phase or constant phase difference, these will be called as your coherent. So they should maintain constant phase difference, or those sources can have same phase, guys, and they should have same frequency also. There is no necessity for coherent sources to have same intensity. They may have same intensity, they may not have same intensity. But two sources of sound or two sources of light emitting sound or emitting light respectively of same frequency and in same phase will be called as your coherent sources, guys. And I can also consider dependent sources, right? Whenever you take dependent sources, they will be coherent. And if you take independent sources, right, independent sources will be incoherent, or I can say they are non-coherent, guys, right? Let us say Again, the sources, coherent sources or incoherent sources, they may be identical, they may be non-identical or unidentical. Let us say if they are identical, n sources which have, if they are identical sources, intensity will be same, guys. So n sources, coherent sources are producing light of intensity I naught. Then in this case, the resultant intensity will be given as n square times of I naught, guys. In the same manner, if independent sources are there, n identical non-coherent sources are there, they are producing, because they are identical sources, intensity will be same. So the resulting intensity will be n times of I naught only, guys. It will be n times of I naught only. Or in general, I can say coherent sources are those sources whose phase difference basically happens to be zero. Non-coherent sources or incoherent sources are those sources whose phase difference usually happens to be pi by 2. Clear, all of you? Yes or no, everyone?
Yes, sir.
Similarly, what is wavefront? You may be aware of equipotential surfaces, guys. So equipotential surfaces and wavefronts, they are similar again. Equipotential surfaces will be perpendicular to the field propagation. Wavefronts will be perpendicular to the wave propagation, guys. So these are locus of all those points which are vibrating in same phase. And what is the important point that you need to remember? These will be perpendicular to the direction of wave propagation. Three types of sources we are going to have. One will be our point source, other one will be line source, the third one will be your plane source. Remembering these are important, guys. For line source, amplitude inversely proportional to r, intensity inversely proportional to r square. Wavefronts will be spherical. For line source, for point source, this was the case. For line source, intensity will be inversely proportional to r, amplitude will be inversely proportional to root r, and for line source, the wavefronts will be cylindrical wavefronts. Or the locus of all those points which are vibrating in same phase will be called as wavefronts. They are similar to your equipotential surfaces, guys. Clear, all of you? In the same manner, we have plane source, guys. Plane source is nothing but plane sheet of charge. For plane sheet of, we'll study in the next chapter, which is probably tomorrow or day after tomorrow, guys. Plane sheet of charge you take. It is only due to plane sheet of charge that we are going to have a uniform field, guys. So that is the reason there will not be any variation of amplitude or intensity with the distance from the plane source. And for plane source, you are going to have planar wavefronts. So these 3 points you should be aware, because if question is asked from waves, usually they will ask questions from loudness level, guys. Loudness level will be 10 log I2 divided by I1 or 10 log I divided by I0 if you are taking only one source. So wavefronts are those, you can consider they are some surfaces which are vibrating in same phase, and they're basically perpendicular to the direction of wave propagation. For point source, spherical wavefronts. For line source, cylindrical wavefronts. For plane source, planar wavefronts. How will intensity and amplitude vary? This also remember, guys. Clear? So basically, we have something called a superposition of waves again. What does superposition of waves state again? Suppose, again, light is also wave. It is an electromagnetic wave, guys. Right? So if we imagine that we have two or more waves traveling in a medium, right? Usually wave relation will be represented by a displacement relation or a pressure relation, right? So imagine it is represented by a displacement relation, guys, and there are two waves traveling in a medium. So whenever they superimpose on each other, so one wave you can take it as a1 sine omega t, right? Or omega t minus kx you can take, because we are talking about a wave, right? Wave will, again, displacement of a particle in wave will vary with both position and time. Oscillations, it will vary only with time, but wave, it will vary with both position as well as time. Y2 value, another wave, let us say it is a2 sine of omega t minus kx plus phi, guys. Okay, so what is y2 called as? Y2 will be displacement at any instant. Y1 and y2 are displacements, guys, at any instant, or instantaneous displacement you can consider. A1 and A2 will be maximum displacements, guys. This complete angle will be called as phase. This also will be called as phase, right? The value of phase at t is equal to 0, x is equal to 0 will be called as initial phase. So what is phase here? Omega t minus kx. Substitute t is equal to 0, x is equal to 0. What will this value become? Substitute t equal to 0, x is equal to 0. What is this value going to become?
5.
0, yeah, first one. 0. So that will be your initial phase, guys. In the same manner, second one you say, if you substitute t is equal to 0, x equal to 0, what will you get the phase as? Phi. So phi will be called as initial phase. So if I am writing only second equation, guys, phi will be the initial phase. Right? What is the phase of first equation? Omega t minus kx. What is the phase of second equation? Omega t minus kx plus phi. Is there any phase difference between both these equations? Yes or no? Is there any phase difference, guys? Yes, there is a phase difference. How much is the phase difference? Phi will be the
Five.
phase difference. Okay. So if I am writing only y2 equation, phi will be initial phase. If I am comparing y1 and y2, phi will be your phase difference, guys. So because they are varying with time, a time varying alternating quantity or time varying periodic quantity can be represented by a phasor. So initial phase of y1 is 0. So that is the reason I can represent y1 in terms of x-axis, a phasor, one vector directed along x-axis. Y2 has an initial phase of phi, guys. Imagine phi is positive. So y2 has more phase. So I can represent the phasor of y2, which is leading phasor of y1 by an angle phi, guys. So here you can take a value as a1, b value as a2. Now you can apply parallelogram law of vectors. So from parallelogram law of vectors, I'll get the resultant displacement, resultant amplitude. You can write it as under root of a1 square plus a2 square plus 2a1 a2 cos phi. Clear? And what is the resultant angle, guys? Theta value I can write it as tan inverse of a2 sin phi divided by a1 plus a2 cos phi. Okay. In the same manner, we know intensity is proportional to amplitude square. So I can write the resultant intensity as I1 plus I2 plus 2 root of I1 I2 cos phi. So for a given sources, I1 and I2 will not change, but there is a possibility for phi to change, guys. Now depending on, so if phi is changing, this cos phi may be maximum or minimum. If it is maximum, you are going to have an interference called as constructive interference. If it is minimum, then we are going to have an interference called as destructive interference. So which formulas are important, guys? The first formula, resulting amplitude is under root of a1 square plus a2 square plus 2a1 a2 cos phi. Resulting intensity will be I1 plus I2 plus 2 root I1 I2 cos phi. Clear, all of you? Understood, everyone? Right. So there is also relation between phase difference and path difference. The relation happens to be this, which is very important relation. Phase difference will be given as 2 pi by lambda times of path difference, guys. So what is phi here? Phi happens to be phase difference. What is delta x? Delta x happens to be your path difference. And lambda value, as you all know, it is wavelength, guys. So this is the relation between path difference and phase. As I said, depending on the value of this cos phi. Now cos phi can either be maximum or cos phi can either be minimum. So if cos phi value is maximum, intensity will be minimum, intensity will be maximum. So whenever resulting intensity is maximum, it will lead to an interference called as constructive interference. It will lead to an interference called as constructive interference. Whenever cos phi value is minimum, the resulting intensity will also be minimum. Resulting intensity minimum, resulting amplitude will also be minimum, guys. So that is the reason this type of interference will be called as your destructive interference. It will be called as your destructive interference. Understood, all of you? So depending on whether resulting intensity is maximum or resulting amplitude is maximum or minimum, interference can be of two types, constructive as well as destructive. Relation between path difference and phase difference is 2 pi by lambda into delta x, guys. Now what is our maximum amplitude? So again, whenever constructive interference takes place, maximas will be formed, guys. Whenever constructive interference takes place, what will be formed? Maximas. Whenever destructive interference takes place, right? Whenever destructive interference takes place, what will be found, beta? minimas will be formed, guys. If destructive is taking place, minima. When constructive interference taking place, maxima. Maxima formations will also be bright fringes formation. Minima's formation will be dark fringes formation, guys. Right? I recently came across one of the very good illustration, guys. Suppose if you take a horse, exactly white horse you take, guys. Okay. Now white horse is made to pass through two slits. Let us say white horse, pure white horse is made to pass through two slits, guys. Right? It is going to get converted to a zebra. Zebra will have white and black strips or not, guys? Stripes or not? Yes or no, everyone? You take a horse, right? You take a horse, pure white horse, guys. Okay. It is made to pass through two slits, let us say. What is it becoming? It is going to become a zebra, which is nothing but Young's double slit experiment again. Right? So white light, you are taking a monochromatic light. So what will happen? You will have alternate bright and dark fringes formation. So that is one of the good illustration I have seen in recent days, guys, to explain Young's double slit experiment. Okay. Now you should also understand or remember the relation for path difference and phase difference, guys. So what would be relation for phase difference? For phase difference, relation will be 2n pi, guys, and n value will start from 0 onwards. And condition for path difference will be n lambda. Here also n value will start from 0 onwards, guys. So what is maximum intensity? It will be root I1 plus root I2 whole square. The maximum intensity, I'll write it here. Firstly, phase conditions for phase difference is 2n pi. N value will start from 0 onwards, 0, 1, 2, so on. What is path difference? Because there is relation between path difference and phase difference, we can find path difference to be n lambda. Again, n will be starting from 0, 1, 2, so on. So what is our maximum amplitude, beta? Maximum amplitude will be sum of individual amplitudes. And what is our maximum intensity? It will be under root of I1 plus under root of I2 whole square. These are conditions for your constructive interference, beta. In the same manner, we have for destructive interference also. Right? For destructive interference, we can write the phase difference to be 2n minus 1 into pi. You can either take 2n plus 1 also, but we usually we ignore 2n plus 1, guys. Here n value will start from 1, 2, 3, so on, guys. Now, sir, constructive interference you took n is equal to 0, but destructive interference you are not taking n is equal to 0. Why? Because whenever light waves interfere constructively, there is something unique with maximas, guys. So there is a central bright fringe formation. So n is equal to 0 corresponds to central bright fringe. You will have central bright fringe, but there is nothing like central dark fringe, guys. So here n is equal to 0 corresponds to central bright fringe. N is equal to 1, first bright fringe. N is equal to 2, second bright fringe. N is equal to 3, third bright fringe. Whereas here n value is equal to 1, first dark fringe. N value is equal to 2, second dark fringe. N value is equal to 3, third dark fringe. Clear? In the same manner, path difference if I consider, you will get it as 2n minus 1 into lambda divided by 2. Here also n value will start from 1, 2, 3, so on. And the max minimum here amplitude will be minimum, guys. It will be given as a1 difference a2, and intensity will also be minimum, which will be given as root I1 difference root I2 whole square. These things you should know in constructive and destructive interference. Depending on the value of cos phi, the resulting amplitude, resulting intensity may either have a maximum value or a minimum value. Right? Whenever they have a maximum value, it will lead to interference called as constructive interference. And whenever the resulting intensity and amplitude have minimum value, it will lead to an interference called as destructive interference, guys. What happens, Adya?
Nothing, sir. By mistake, Little.
Is that clear, all of you? Yes or no? Now they will ask you this very important thing, guys. This is a very important formula that you need to remember. The ratio of maximum to minimum intensity, it will be given as root I1 plus I2 divided by root I1 minus I2 whole square, or root beta plus 1 divided by root beta minus 1 whole square. There is also one very, very important term called as fringe visibility, guys. We'll study this in YDSC, Young's Double Slit experiment. Young fringe visibility is nothing but the ratio of difference between maximum and minimum intensity to the sum of maximum and minimum intensity. This is called as fringe visibility. It is the ratio of difference between maximum and minimum intensity as well as sum of maximum and minimum intensity, guys. And how will I give this? It will be given as 2 root I1 I2 divided by I1 plus I2, or I can write it as 2 root beta divided by beta plus 1. Clear all of you? Beta is nothing but I1 by I2. This is your fringe visibility given as the ratio of difference between maximum and minimum intensity and sum of maximum and minimum intensity. Clear all of you? Now, as I said you before, the sources that we are taking can either be identical or unidentical, non-identical, right? So if they are identical, the intensities will be same, guys. So if I take same intensities, if I1 and I2 will be same, then our maximum intensity will be given as 4I naught. Minimum intensity will become 0. And resulting intensity is given as 4I naught cos square 5 by 2, guys. Right? Maximum intensity 4I naught, minimum intensity 0. Resulting intensity will be given as 4I naught cos square 5 by 2. Clear all of you? And as I already said before, if you take incoherent light waves or sound waves, guys, right, you are going to just add them. I value resulting intensity will be I1 plus I2 plus I3 plus I4 plus I5 plus I6 plus so on. It is also very, very important again. So for superposition of incoherent, non-coherent waves, what will the resulting intensity be? It will simply be algebraic sum of individual intensities. Clear? Is that clear all of you? Yes or no?
Yes, sir.
Sir, 4
Yes,
I
sir. Yeah, 4.
sir 4 I naught and I max is 4 I naught and I minimum is 0. That is only for
If they are taking
for
identical.
only for identical,
Identical, coherent.
identical and coherent.
Coherent, you can, because again, for interference to take place, definitely sources have to be coherent again. So that is the condition. Okay.
Okay.
Identical you can take. Okay. Now, if you talk about interference, three phenomena of light we will study. One is interference, other is diffraction, the third one is polarization. So interference basically takes place because of superposition of waves, guys. Okay. Diffraction will take place because of superposition of secondary wavelets. Diffraction will take place because of superposition of secondary wavelets, right? Polarization is again a phenomena of light in which an unpolarized light gets converted into a polarized light. What is unpolarized, polarized, we will talk about in some time. But interference, please remember, it will take place due to superposition of waves. Diffraction will take place due to superposition of secondary wavelets. Polarization is a phenomena of light which takes place only in those waves which are transverse in nature, guys. So sound, if you take, it cannot be polarized again because polarization takes place uh, in transverse waves only. It cannot be taking place in longitudinal waves, guys. Okay. So please remember that. So Young's double slit experiment will appear to be something like this. Okay. I'm directly showing it. We cannot explain everything in detail again, guys. So please listen. So if I want one very important point, if I want interference to take place continuously, sustained interference means interference has to take place continuously. So for interference to take place continuously, our sources have to be coherent. And how we can derive coherent sources, guys? Suppose every time I use this same concept again. If we are in a dark room, let us say we are dividing the dark room with a certain cardboard partition, guys. In one half of the room, I am keeping a torchlight turned on. In other half, you are standing, let us say. And in cardboard, you are making two very small, fine holes, guys. So will you be able to see light coming out from the fine holes or not? Yes or no? Yes, obviously. So those fine holes can be considered as sources. But for you, those are the sources. But what is the real source, guys? Torchlight is the real source. So we got two new sources from a single source, guys. So whenever two sources are derived from a single source, so are these two sources depending on the torchlight or not? And dependent sources are called as coherent sources, guys. So that is the reason we can consider sources if they are for if I want interference to take place continuously, the sources have to be coherent. And how can we derive coherent sources, guys? You can take two sources derived from a single source that will behave as coherent source, guys. So the experimental apparatus will be something like this. You will have two slits here, S1 and S2, and the actual source will lie on the perpendicular bisector of S1 and S2, guys. Actual source will lie on perpendicular bisector of S1 and S2. Now you see S2 S1 S2 S2 same distance. From source light will come, guys. You can consider one light wave like this, you can consider another light wave like this. S2 S1 S2 S2 same distance. Are ha ya na yaar? Yes, you will get same distance. S1 to O, S2 to O same distance. Yes or no yaar?
Yes.
Yes.
Right, so before reaching the slits SS1 SS2, they will travel same distance. So will there be any path difference? No. After crossing the slits S1 to O, S2 to O, same distance or not? Yes. So at point O beta, is there any path difference? No path difference. And no phase difference also. At whichever point you don't have path difference or you don't have phase difference, there you are going to have central maxima formation or central bright fringe formation, guys. There you are going to have central maxima formation or central bright fringe formation. So always remember, central maxima will be formed at a point where there is no path difference, where there is no phase difference. Now what I'll do, very simple logic. I am shifting the source upwards, let us say. Now before reaching the slits, which ray will travel more distance? If I am shifting the source upwards, SS1, SS2, which will travel more distance?
SS2.
Yes or no? Let us say this is first wave, this is second wave. Okay. So before reaching the slits, if I am shifting the source upwards, which will travel more distance? Second one. Right? If I want path difference to be 0, after crossing the slits, which wave should travel more distance? Are you getting my point? Path difference 0 means both the waves should travel same distance and reach a point. Okay. So I have shifted the source upwards, guys. Initially, when the source is lying on the perpendicular bisector of the slits, SS1, SS2 same, S1O, S2O same. Now I have shifted the source upwards. What is going to happen? First wave will travel less distance or not, guys? Second wave will travel more distance. So after crossing the slits, which light should travel more distance in order to make path difference 0? You got?
Second.
Arey bhai. Source is shifted upwards. S2, S1, less distance. S2, S2, more distance. Second wave travel more distance before reaching the slits. So if I want path difference to be 0, after crossing the slits, which wave should travel more distance?
S1.
Which one? The light which is coming from first one. So when will light coming from S1 travel more distance? If the point gets shifted downwards. So always remember, if the source is lying on the perpendicular bisector of the slits, central maxima will be formed at point O, guys. Okay. Whereas if you are shifting the source upwards, central maxima will get shifted downwards by same distance. In the same manner, if you are shifting the source downwards, which will travel more distance before reaching the slits? If you are shifting the
S1.
source downwards, which will travel more distance, beta? First wave will travel more distance. Now I want to find a point where there is no path difference. So after crossing the slits, which should travel more distance?
S2.
S2. When will it travel more distance? If the point O is shifted above. So whenever source is shifted upwards, central maxima shifts downwards. Whenever source is shifted downwards, central maxima will shift upwards. And this shift will be same as that of the shift in the source. Clear all of you? How can you locate or identify central maxima? You can identify central maxima. Central maxima will lie at a point where there is no path difference, where there is no phase difference. Clear? Yes or no? So we will take some arbitrary point, guys. At this point, waves are interfering. So I am not saying that point P will be central maxima. Point P can be either any point. Either it can be maxima or minima, guys. Okay. So you see S to S1, S to S2, same distance? Yes. But S1 to P, S to P, which has traveled more distance? S to P. So if you take any arbitrary point which is at a distance y from central maxima, there will be some path difference, guys. And that path difference in general, if you look at the path difference, that path difference in general will be given as d sine theta. And if you take the geometry, we will get that as y into small d divided by capital T. So what is condition for maxima? Path difference should be n lambda. For minima, 2n minus 1 lambda by 2. So these cases, these are very important. These are your positions of nth maxima, guys. What are these? These are positions of this position of nth maxima or nth bright fringe. Substitute n is equal to 0. What will you get y value? If n is equal to 0. So you just come back to the diagram. If y value is 0, this is y. If y value is 0, what will happen to point P? Will it come and coincide with point O or not? Point O is nothing but your central maxima or central bright fringe. Clear all of you? Yes or no? In the same manner, these are our positions of nth dark fringe, guys. This is our, these you should remember, guys. This is our position of nth minima or nth dark fringe. This you should remember. So positions of maxima will be n lambda capital D by small d. Positions of minima will be 2n minus 1 lambda capital D divided by 2d, guys. Okay. So calculating number of maximas minimas formed will also be there. So I'm not dealing with that as of now, right? If you want, we can deal, but they are not required because their questions have not been asked. If they are being asked, let us see. If one or two questions have been asked in the questions, we will discuss those questions. But as of now, it is not required. Okay. Now, very basic logic. So these points you should remember. So at point at O, if source is lying on the perpendicular bisector, you will have central maxima formation. And at central maxima, intensity will be maximum. If I take both these slits to be identical, maximum intensity will be 4I naught. At any point P, guys, P is any arbitrary point. Anything can form at that point. Okay. So either maxima can be formed or minima can be formed. So the intensity at any point will be 4I naught cos square 5 by 2. This is in terms of phase difference, right? This is in terms of position, guys. And this is in terms of fringe width. What is the meaning of fringe width? It is nothing but distance between two maximas or two minimas. So it is given as lambda capital D by small d, right? This is not given as lambda by alpha, guys. Okay. It is not lambda by alpha. So here alpha will be your angular fringe width, guys. It is given by lambda divided by small d. Okay. So beta is fringe width, lambda alpha is your angular fringe width, guys. And if they are asking in terms of path difference, I can also write it in terms of path difference. It will be 4I naught cos square. What is phi? Is it 2 pi by lambda into delta x or not? So I can write it as pi by lambda into delta x. So these you should remember. Even if you don't remember this, not a big deal, guys. Please remember that at point O, if source is lying on perpendicular bisector, at point O you will have central maxima, and at central maxima intensity will be maximum. Usually that maximum intensity, if the slits are identical, it will be given as 4I naught. And intensity at any point will be 4I naught. So sometimes no, they may not give 4I naught as the maximum intensity. They will simply say I naught is the maximum intensity, guys. So you be very careful. So instead of writing 4I naught, you should write I naught only in that case. Basically, it is maximum intensity into cos square phi by 2. In general, 4 I naught you will get, but in questions, no. If I naught is the maximum intensity, they will give. So then you will write intensity at any arbitrary point as I naught cos square phi by 2, I naught cos square pi by lambda delta x, I naught cos square pi by small d divided by capital D, right? And I naught cos square pi by beta. Beta is called as your fringe width beta. What is beta here? Beta happens to be fringe width. It is the distance between two maximas or two minimas. And what will alpha happen to be? Alpha happens to be angular fringe width beta. It is your angular fringe width. So you know distance, you know nth maxima, which is n lambda capital D by small d. You know nth minima. I can write it as 2m minus 1 lambda capital D by 2d. So if maxima and minima are lying on the same side, if they both are lying above central maxima or below central maxima, they'll ask you to find distance between them. So then I'll write this will be the distance. I'll subtract their positions, guys. If they are lying on the opposite side, then I will add them. Okay. So what are the things as of now you need to know? First is position of bright fringes. What are positions of bright fringes? N lambda capital D by small d. Then I need to know position of dark fringes. What is it? 2n minus 1 lambda capital D by 2d. Capital D is distance between screen and the slits, guys. This is your capital D, as you can see. Small d is distance between the slits, guys. Capital D is distance between screen and slits. Small d is distance between the screens. Okay. Right. So those two formulas are very important again. Right. So they will ask you what is distance between fifth maxima and second minima. So can you locate fifth maxima and second minima? Yes. If they are lying on the same side of central maxima, then you will, in order to find distance between them, you will subtract both of them. If they are lying on the opposite side, in order to find the distance between them, you are going to add both of them, guys. We have also studied what will be the maximum intensity. Again, I am saying that slits are identical. So if slits are identical, maximum intensity will be at central maxima, which is 4 I naught. Intensity at any arbitrary point will be 4 I naught cos square phi by 2. And fringe width will be given as lambda capital D by small d, where lambda by small d will also be called as angular fringe width. Now what I'll do is I'll take this Young's velocity apparatus and immerse it in some medium. Capital D value will not change. Lambda value will not change. However, in different media, wavelength is different or not. The wavelength will change, guys. Usually, whenever I'm dipping it in some denser medium, wavelength will decrease. So as you can see, so whenever YDSC experiment is kept in a medium, what will happen to fringe width? Fringe width will become decreased by mu times. However, intensity of the fringes, it will remain same, guys. Okay. And very important case again, the next case, I have taken slits to be identical. Suppose if slits are not identical, then in that case, what will happen? So till here, everything is sufficient, guys. Actually, till fifth point, the other points are little bit not necessary to be precise. Some points are not necessary. I cannot say all the points are not necessary, right? So whenever the slits are non-identical, guys, one has 5 centimeters thickness, other has 2 centimeters thickness, then these are non-identical. So if they are non-identical, these are very important cases. Whatever dark fringes are there, initially they may have very high darkness. Now what they will happen, guys? They will become slightly brighter. Whereas bright fringes, they are going to become less bright. Okay, maximas will become less bright. Minimas will become slightly brighter. They are actually very dark. Now they will appear to be less dark, or they will appear to be slightly brighter. Whereas bright fringes, they are going to become less bright, guys. In the same manner, right? Whenever white light, what is monochromatic light basically? Monochromatic light is a light of single wavelength, guys. Monochromatic light is what? It is a light of single wavelength. So if we are using white light has a possibility to split into 7 different colors, guys. So whenever white light is used, what is going to happen? Colored fringes will be formed, guys. And how will those colored fringes be? The central fringe will be white in color, right? And all other fringes will be colored. First maxima it will be violet in color, and you take one point, guys. Some point we have taken. Let us say point O is central maxima. I have taken point P, which is at what distance? It is at some y distance. The white light is a combination of different wavelengths, guys. If I am using lambda 1 wavelength, let us say here at point P, n1th maxima of lambda 1 wavelength is formed. Also, at the same point, n2th maxima of lambda 2 wavelength is formed. Please tell me what is the general formula for position of maxima? Is it n lambda capital D by small d or not? So white light is a combination of different wavelengths. So if I am using lambda 1 wavelength, what is formed at point P? N1th maxima. So what we can write y value as, beta? I can write it as n1 lambda 1 capital D by small d. And also at point P, what is formed? N2th maxima is formed. So I can write it as n2 lambda 2 capital D by small d. You see, left hand sides of both the equations are same. Can I equate the right hand sides or not? Yes, I can equate the right hand sides. This is a very, very important concept, guys, because previously twice you have got questions from this. N1 lambda will be equal to N2 lambda 2. Right? So what we can consider? You can write N1 by N2 as N1 by N2, you can take it as lambda 2 divided by lambda 1. So whenever white light is used instead of monochromatic light, at one point you may have maximas of different wavelengths coinciding, guys. And what is the condition for maximas to coincide? Directly I can write n1 lambda 1 will be equal to n2 lambda 2. It's a very, very important point. So two wavelengths may have maxima at the same position, guys, provided n1 lambda 1 will be equal to n2 lambda 2. It's a very, very important. Suppose I am saying two lights of wavelength 5000 and 6000 angstroms are used. What is the position of a point where maximas of these wavelengths coincide? They will ask, guys. So I have taken two wavelengths. What were these wavelengths? One was 5000, other is 6000. So what I can write here? Can I write it as 6000 divided by 5000 or not? So what will I get, beta? I'll get it as 6 by 5. Yes or no? Are they co-primes? Yes. So what I can say? I can directly write n1 value will be 6, n2 value will be 5. So in this situation, I can say sixth maxima of first wavelength will coincide with fifth maxima of second wavelength. They will ask you to find the position, guys. How will you find the position? Now, very direct. So I can write it as 6 lambda 1 capital D by small d, or you can write the position as 5 lambda 2 capital D by small d. Capital D and small d will be given. They will ask you to find the position of the point where maximas are coinciding. So what is the condition for maximas to coincide at a point? N1 lambda 1 should be equal to N2 lambda 2. Wavelengths will be given. From there you can find N1 and N2. From there you can find value of Y. Clear, all of you? It's a very, very important case. Previous years questions were asked from this particular concept. Understood? Yes or no?
Yes, sir.
Now what we do is, the 8th point is also important, guys. What I'll do, I'll take a thin film. You can assume a soap bubble, guys. So I'll take a thin film and I'll introduce it in front of either up the above slit or the below slit. So let us say in this case, if one of the slits, let us say they have taken S1, is covered with a thin film, guys, then what is going to happen? Now central maxima will not be formed at point O, guys. Very important case. So at point O, path difference is not 0. So where will central maxima be formed? It will be formed at a point where there is no path difference. Yes or no? But at point O, whenever you are introducing a film in front of S1 or in front of S2, at point O there will be path difference. So that is the reason central maxima will not be formed at point O. What can be formed at point O? Either a maxima can be formed or a minima can be formed. So what we need to know is, we need to know this particular value, guys. So there will always be a certain initial path difference which is given as mu minus 1 into t. I am not going in detail about everything again. So whenever we are introducing a thin film in front of one of the slit, between the two waves there will be some path difference mu minus 1 into t. At point O, there will again be path difference. So central maxima will not be formed at point O. What can be formed? Either a maxima can be formed. When will maxima be formed? When initial path difference is equal to n lambda. Okay. When will minima be formed? When initial path difference is equal to 2n minus 1 lambda by 2. Okay. Now, because you have introduced a thin film on the above slit, the central maxima also, guys, it will get shifted upwards. What will happen? Central maxima will get shifted upwards. By how much distance will it get shifted upwards? It will get shifted upwards by distance mu minus 1. This is very important formula again. So whenever a thin film is introduced in front of any slit, fringes may either shift upwards or downwards. If you are introducing a film on before the above slit, then the central maxima will shift upwards, fringes will also shift upwards. If you are introducing a thin film in front of the below slit, central maxima will get shifted downwards and the fringes will also get shifted downwards. So by how much distance are they going to shift, guys? This formula, mu 1 minus t, mu minus 1 into t, capital D by small d. Or I can write mu minus 1 into t, beta by lambda. So if central maxima is shifting, fringes will also shift. How many fringes are shifting? They are asking, guys. So number of fringes shifted upwards. It is also very important formula. It will be mu minus 1 into t divided by lambda. So this is also important case. However, the fringes are shifting, but fringe width will not change. Fringe width will not change. And I have already said, if source is displaced upward, central maxima will shift downward. I have said this point, so I'm not discussing that. So these are some major points that you need to remember in Young's double slit experiment, guys. Position of maxima, position of minima, fringe width, angular fringe width, distance between maxima and minima, right? What, where will the location of central maxima be, right? What will happen if source is shifted upwards? What will happen if source is shifted downwards? What will be the intensity at any arbitrary point? What is the intensity of central maxima, right? Similarly, if white light is used, what will happen, right? If two slits are not emitting light of same intensity, what will happen? If thin film is introduced in front of one of the slit, what will happen? So these cases, the corresponding formula you should definitely know. I hope it is clear, all of you. Yes or no?
Yes, sir.
Now diffraction is
Sir,
a very
sir, for central maxima, what will be intensity?
in which case?
Sir, in that case you told, for arbitrary it will be 4 I naught. For
But
central
no, no,
maxima,
no. When did I say arbitrary 4 I naught? For maximum only I said 4 I naught. For arbitrary it
for
will be 4 I naught cos square 5 by 2, which is intensity of central maxima into cos square 5 by 2, or intensity of central maxima into cos square pi by lambda delta x, intensity of central maxima cos square pi y by beta, intensity of central maxima cos square pi small d y divided by lambda capital D. Okay, this is the intensity of arbitrary point. Understood? Diffraction is also very simple topic, guys. Now this topic or this phenomena is observed daily, guys. Let us imagine early in the morning, right? Very early in the morning, guys. So as soon as the sun rises, let us imagine there is a small hole in your window or there is a small hole in your door. So will you observe a stream of particles moving in a form of a beam or not, guys? So light will be allowed by that hole and it will be blocked by the other part of the window or other part of the door. So that is only your diffraction. And I have also told you yesterday, diffraction is also bending of light, but where? At edges, at openings. So phenomena of bending of light at edges or openings is also called as diffraction, guys. Okay. Now, usually we will talk about diffraction by single slit, and as I said, diffraction will be due to superposition of secondary wavelets. Okay. Now, I'm not going into the explanation of diffraction again, but basic things you should remember, guys. Very important thing. In Young's double slit experiment, you will have maxima minima formation. In diffraction, because it is due to superposition of secondary wavelets, you will have secondary maxima and secondary minima formations, guys. Okay. So what will you write here? Very basic things, please remember. See this formula: a sine theta n is equal to n lambda. This will be for nth secondary minima. This will be for nth secondary minima. In the same manner, a sine theta n will be equal to 2n plus 1 into lambda by 2. This will be for nth maxima, guys. Okay. Nth secondary maxima again. Two formulas you need to know. A sine theta will be n lambda for destructive interference. It will be reversed here. And a sine theta will be equal to 2n plus 1 lambda by 2 for constructive interference. Nth maxima will be formed here. And n value will start from, you can take n value here will start from 1 only, not from 0, guys. Okay, here also n value will start from 1 only, 1, 2, 3, so on. Okay, so these 2 points are very important again. So diffraction by a single slit only we usually use. So what is the condition for minima's formation? A sine theta should be n lambda. What is the condition for maxima's formation? A sine theta. A is nothing but the opening. You will have only single slit, one slit only you have. In Young's double slit experiment, you will have 2 slits. So A is nothing but width of the slit. It is similar to small d, guys. Okay. So A sine theta 1 will be 2n plus 1 lambda divided by 2. So suppose if I want to find first minima, what will I substitute n value here? What will I substitute n value here? 1 only or not? So what will be angular position? This is formula important. Angular position of first minima is sine inverse lambda by A. In the same manner, what will be angular position of nth minima, beta? Angular position of nth minima I want to find. It will be sine inverse of n lambda divided by A. In the same manner, I want to find angular position of nth maxima, guys. Very, very important again. It will be given as sine inverse of 2n plus 1 into lambda divided by 2a. Okay. Again, these two also are important. This is condition for secondary maxima formation, condition for secondary minima formation. This is angular position of first minima. This is angular position of nth minima. Right? This is angular position of nth maxima. If I want to find angular position of first maxima, I'll substitute n value as 1. You will get sine inverse of 3 lambda divided by 2a. Okay. Similarly, you also have angular spread of central maxima. Angular spread of central maxima will be 2 sine inverse lambda by a, and I can write it as 2 lambda by a. When I can write 2 lambda by a? Only when wavelength of light used is less than the width of the slit. And very important point, if wavelength of the light used is more than width of the slit, diffraction cannot take place, guys. Diffraction cannot take place. In the same manner, you will have width of central maxima, which is 2 lambda capital D by small a. Width of any other fringe will be lambda capital D by small a. And in the same manner, if I take I naught is the intensity of central maxima, there, what was the intensity of central maxima we took in Young's double slit experiment?
4 I naught.
4 I naught. Here they are saying if I naught is the intensity of central maxima, then nth maxima intensity will be given as 4 I naught divided by 2n plus 1 whole square pi square. It is also very important. So as n value keeps on increasing, what will happen to intensity? It goes on decreasing. So usually in diffraction, intensity goes on decreasing. In interference, intensity will remain same. In diffraction, you see, width of central maxima is 2 times the width of any other fringe. Whereas in interference, width of all the fringes, whether you take central maxima, whether you take second minima, whether you take fifth maxima, you take width of any fringe, it will be same, which is lambda capital D by small d. Clear all of you? Yes or no, everyone? Is that clear, all of you? So we have discussed regarding Young's double slit experiment, and we have also discussed regarding diffraction. We will discuss polarization tomorrow. It's hardly 15 minutes, guys. So we'll discuss that tomorrow and solve questions of wave optics tomorrow. Any doubts in today's session, all of you?
So why
Sir,
don't
Sir?
sir, at last you told if I naught is intensity of central maxima, it is 4 I naught, no? So if
No, I
any
didn't
other,
say 4 I naught. I said 4 I naught is the intensity of central maxima in Young's double slit experiment.
okay,
And here, if they are considering I naught as the intensity of central maxima. Okay.
okay.
4 I naught is the intensity of central maxima in Young's double slit experiment. Here, if I want to use the formula 4 I naught by 2n plus 1 whole square pi square, I should take I naught as the intensity of central maxima. Okay. Clear, all of you? Yes or no? So please remember these formulas in diffraction, right? What is the condition for secondary maxima formation? Condition for secondary minima formation? What is angular position of first minima? What is angular position of nth minima? What is angular position of nth maxima? What is angular position of first minima? What is angular spread of central maxima? Width of central maxima? Width of any other fringe? And what will be intensity of nth maxima? These 10 points in diffraction, 10 formulas you remember. Okay, similarly around 10 points in Young's double slit experiment. You will have 2-3 points only in polarization that we will be discussing in tomorrow's class. Clear, all of you?
so
जी बोलिए sir.
So why don't we consider the value of n as 0 in any of the equations for finding the
Where
so in diffraction?
diffraction?
Yes.
Central maxima I want. No, I cannot write n is equal to 0 here.
So I didn't understand.
In which case you are saying? In
Sir,
diffraction, why am I not writing?
why are we not considering n is equal to 0 for any of the two cases, even for nth minima or
Where? Because central maxima in interference, central maxima, first maxima, second maxima, third maxima, they have similar features. Whereas in diffraction, there is a central bright spot which is different from the other bright spots. So that is the reason we don't define the angular position of central maxima. If you look at the diagram, right, you have very simple logic. Let us say this is your first minima. Minima can be below also. So how will the fringes be? I'll tell you. If I say we have central bright fringe here, above you will have first minima. This is the fringe pattern. First minima, first maxima, second minima, second maxima, third minima, third maxima. Similarly downwards. If this is central maxima, first minima, first maxima, second minima, second maxima, third minima, third maxima. So why I have not taken n is equal to 0 is here we define the central maxima with regards to first minima. So if I say here first minima is there, here also on the opposite side first minima is there. It means from here to here, completely you have spread of central maxima. So here I am defining central maxima with the positions of first minima. That is the reason I am not writing n is equal to 0 anywhere. Clear?
Yes, sir. But
Any other?
actually the formation of central bright maxima takes place. Right?
There is no secondary central bright maxima. Okay. Here secondary maximas will form. There will not be any secondary central bright fringe. That is the reason we don't write n is equal to 0. There is a central bright fringe. There is a maxima. There is a secondary maxima. There is a minima. There is a secondary minima. There is a central bright fringe, but there is nothing called a secondary central bright fringe. Okay. So that is the reason in any formula we don't use n is equal to 0.
So for that central part, what will be the n value?
We are not using, no, I am defining central maxima with first minima. So why do I need n value? Are you getting my point?
Yes.
It is spread. It is not one spot. It is spread completely. Okay.
Yes, understood.
If it was a point, I would have defined what should be n value to find out theta. But it is not starting again. It is not a point. It is a complete spread. So it is a collection of points. So I cannot say n is equal to compulsory this value only. However, you can define y value. Y value will be 0, you can say. Okay. So that cases you can take. You can also consider n value 0. It's not a big deal. If you take n value 0, you will get theta value 0 only. Okay. Right. So these I have discussed some points, guys. So rest of the points we will see tomorrow, and rest of the questions also we will solve tomorrow. Maximum questions of wave optics will complete tomorrow. The test paper is already ready. As soon as the class is completed, I'll share the test paper, 1 hour time, and it is a tick 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 chalte jata time. Okay, your progress will also be seen in that, so you can check that, guys. And hopefully, if you write so those tests, it will be helpful to you. Okay. Chalo, we'll meet tomorrow, guys. Okay. Till then, take care, everyone. Thank you all. Please solve the previous year questions of ray optics. Complete it today. By tomorrow, you complete it, guys. Okay. Is that clear?